Welcome to this video on the UPLT syllabus for mathematics. This video will guide you through the key topics you need to master for your upcoming examination. Your goal is to achieve rank 1. Remember that consistent practice and hard work, combined with following the right path, are the keys to your success. The examination consists of 2 tiers, a Tier 1 objective paper and a Tier 2 written paper. In the Tier 1 objective paper, you will face 120 mathematics questions worth 240 marks and 30 general knowledge questions worth 60 marks. The Tier 2 written paper focuses on mathematics, consisting of 10 short type questions worth 80 marks and 10 long type questions worth 120 marks. The syllabus covers 7 core subjects: algebra, real analysis, vector analysis, complex analysis, calculus, geometry, and statistics and probability. Starting with algebra, the first chapter covers the theory of equations, including linear, quadratic, cubic, and biquadratic equations, as well as the relationship between roots and coefficients. Next in algebra are sequences and series. You should be familiar with arithmetic, geometric, and harmonic progressions, along with the sums of squares and cubes of natural numbers. Continuing through algebra, topics include permutations and combinations, the binomial theorem, exponential and logarithmic series, and set theory, focusing on algebra of sets and Venn diagrams. The syllabus also includes relations and functions, covering types of relations, equivalence relations, various function types, and the composition and inverse of functions. You will also study binary operations in groups, including operations on a set, groups and subgroups, quotient and cyclic groups, permutations, Lagrange's theorem, and group homomorphism. Moving to matrices and determinants, key areas are types of matrices, algebraic operations, symmetric, skew-symmetric, Hermitian, and skew-Hermitian matrices, as well as inverses and rank. The applications of matrices are also essential, specifically for solving systems of linear equations, finding eigenvalues and eigenvectors, and using the Cayley-Hamilton theorem. In the second major subject, real analysis, you will begin with the study of sequences of real numbers, including their definitions, bounded sequences, and monotonic sequences. Finally, for real analysis, you should master the convergence of sequences, including convergent and divergent sequences, and the calculation of sequence limits. Moving on to the series of positive terms. This section of the syllabus covers the convergence of infinite series and various tests for convergence, such as the comparison test, Cauchy's nth root test, the ratio test, Rabe's test, and the logarithmic test. Further exploration of series includes advanced convergence tests like De Morgan's and Bertrand's tests. You will also cover alternating series, including their definitions and the application of the Leibniz test. Our next major subject is vector analysis, which starts with the introduction to vectors, their basic concepts, and various types of vectors such as unit, null, equal, and opposite vectors. The syllabus continues with vector operations, specifically the addition and subtraction of vectors, scalar multiplication, and finding the linear combination of vectors. You will then study the dot product or scalar product of vectors, followed by the cross or vector product, focusing on their definitions, properties, and practical applications. Vector analysis also includes the study of triple products, both scalar and vector, as well as vector differentiation, covering derivatives of vector functions and their physical interpretations like velocity and acceleration. The final part of vector analysis covers gradient, divergence, and curl. This involves understanding the gradient of a scalar field, the divergence and curl of vector fields, their geometric meaning, and their applications. We now transition to complex analysis, starting with complex numbers. You will cover the basic algebra of complex numbers, including modulus, argument, and their polar and exponential forms. You will also learn about De Moivre's theorem, including its statement, proof, applications, and finding nth roots. This section also introduces functions of a complex variable, their limits, and continuity. For differentiability and analytic functions, you will study the conditions for differentiability of complex functions and explore the properties of analytic functions. The Cauchy-Riemann equations are critical here, as they provide necessary and sufficient conditions for analyticity. You will also cover elementary functions, including exponential, logarithmic, trigonometric, and hyperbolic functions. Finally, within complex analysis, you will study harmonic functions, focusing on their definitions, examples, and their relationship with analytic functions. Our final subject is calculus. This chapter focuses on limits and continuity, covering the fundamental concept of the limit of a function and how to determine continuity at a point and over an interval. This video has outlined the core subjects and chapters for your examination. We hope this summary helps you organize your study plan effectively for the upcoming test. Thank you for watching this video. Stay focused, stay organized, and good luck with your preparation for the UPLT examination. Moving further into the calculus syllabus, we explore differentiability and key theorems. This includes understanding the differentiability of functions, Rolle's theorem, Lagrange's mean value theorem, and L'Hospital's rule. Additionally, you will study successive differentiation. This involves mastering higher-order derivatives and applying Leibniz's rule for products of functions. Calculus also covers practical applications. You will learn about tangents and normals, how to identify increasing and decreasing functions, and how to calculate the maxima and minima of functions. Next, we focus on functions of two variables, where you will study limits and continuity, as well as partial differentiation and its various applications. Integration is a major component, covering indefinite integration techniques like substitution, integration by parts, and partial fractions, along with definite integrals and their properties. You will also apply these integration techniques to find the area under curves, determine the length of a curve, and calculate the surface area and volume of solids of revolution. For first-order differential equations, the syllabus includes both the formation and solution of these equations, with a specific focus on first-order and first-degree differential equations. We now move to the subject of geometry. This section starts with second-degree equations in two variables and their classification into circles, parabolas, ellipses, and hyperbolas. You will also study the asymptotes of a hyperbola and the transformation of coordinate axes, which includes both the translation of the origin and rotation of the axes. In three-dimensional geometry, you will cover direction cosines and direction ratios, as well as Cartesian and vector equations for lines, including conditions for coplanarity and skewness. The syllabus for 3D geometry continues with planes. You will learn to find the equations of planes, calculate angles between planes or between a line and a plane, and determine the distance of a point from a plane. You will also study three-dimensional shapes, specifically the equations and properties of spheres, cones, and cylinders. The final subject is statistics and probability. You will start with frequency distributions, including data collection, the preparation of frequency tables, and graphical representation methods. You will also master measures of central tendency, which include calculating the mean, median, and mode for both grouped and ungrouped datasets. Finally, this section covers probability, including basic concepts, sample spaces, addition and multiplication theorems, and the distinction between independent and dependent events.